Welcome to CW 3.5. Today we're going to finish up our study of inverse functions. So first recall that f of x is equal to y, so f inverse of y should equal x. So we can put a box around that. So it's important to think about because if you look at this graph right here, it says use a graph of f to draw the inverse of the function. The essential thing to think about is this. You simply switch x and y. And you can see how that's happening here. F of x is y, so f inverse of y must be x. So look at these coordinates. 4, 2 should become 2, 4. Negative 1, 0 is 0, negative 1. And negative 3, negative 2 is simply negative 2, negative 3. Now I'll just connect it like so. And right there is our inverse graph. Now you might notice that there's some symmetry here. If I were to draw a line right through the origin like this, notice how there's perfect symmetry over that line, and that line would be y equals x. So essentially, f and f inverse are reflections over y equals x, which makes sense because you generate the inverse by switching x and y. So just write that down, and that's really all you need for this first part of the lesson. Now we're going to do a little harder question. Find the inverse of x squared minus 1, and I want you to highlight this. This is actually quite important. And then it says graph it in the same coordinate system. So notice how that gives you a restriction. That is actually super important, because if I were to graph it without it, it would look something like this. So here's a parabola, and then we have right here. If I told you to find the inverse of this function, this would be impossible because it fails the horizontal line test, which is why there's this thing right here. So I'm actually going to erase this half. So here's my original function right there is f. Now the inverse, we're going to find it algebraically like we practiced yesterday. We're going to switch x and y. So x should equal y squared minus 1. So y squared is equal to x plus 1. So it's square root. And this is the absolute value of y, is the root of x plus 1. So y should be plus or minus the root of x plus 1. And this is why this is so important, because this tells you which one you want. Because it says x is greater than 0, that means you're going to cross out the negative 1. So f inverse is going to be the root of x plus 1. In the event that this part said less than 0, then you would have to take the negative answer. So this part is extremely important. So really put a note there. That is extremely important. You can definitely expect that I'm going to quiz you on that topic or test on that topic. It's a very good topic. So now let's graph the inverse function. Some people like to graph it from here. I like to just flip the points. So if I look at my original, I'm going to flip the points. So I have negative 1, 0, 0, 1, and that would be 3, 2. And I'll sketch it. There's my f inverse. The final thing to do is we're going to do domain and range. And it's important that you organize it the way I'm doing it right here. We're going to make like a mini chart in a way. Notice the domain of f is simply 0 to infinity. And now notice the domain of f inverse. That would be negative 1 to infinity. Now notice the range of f. The range of f is negative 1 to infinity. Now notice the range of the inverse. The range of the inverse is 0 to infinity. So notice how I'm coloring it. That's on purpose because the domain of the original becomes the range of the inverse, and vice versa. The range of the original becomes the domain of the inverse. A pretty cool trick you can use to help you solve these questions.